So we're gonna basically do this moles question, and then we're going to imagine a percentage yield question as a follow-up question on it. So what I've done here in all mole questions, I would suggest that you highlight or underline what you consider what is the known substance and the thing that if you've got some information about, usually the mass, and what is the target substance, which is the one that you're trying to find out. So we know about the magnesium, and we want to find out the mass of the oxygen. So what we do next is so that's our first step. Okay, I've made another video which talks about these steps earlier on. The second step is to work out the molar mass. So let's just go to the periodic table to do that. So we've got the molar mass of potassium. So molar mass. So whenever you're doing the molar mass, just make sure to not just write K equals 24 grams, because then you might think later on that the mass of potassium is 24 grams. That's just the molar mass. The mass, if I had 1 mole, it would be 24 grams. If I had 1 mole of oxygen, it would be 32 grams. Don't forget, if you've got a little 2 down here, to multiply that by 2, just in the same way as any other molecule or compound. If it was H2O, we wouldn't add hydrogen plus oxygen, we'd multiply the hydrogen by 2. And for the same reason, basically, we do that there. So we've got the molar masses. We've identified the known and the target substance. The next stage is to convert the mass that we've got of the known substance into the amount of moles. So we've got there is a formula to do this, but I always think it's a good idea to try to just work out the formula from common sense. If we know that the molar mass of magnesium is 24 grams, then clearly 48 grams is going to be 2 moles. So the mass is going to be equal to the number of moles multiplied by the molar mass. That just makes sense, right? Which means we don't need to memorize the formula. We can just work it out using a bit of common sense. Now, because of that, we can then convert this equation. So moles is going to be equal to mass divided by molar mass. So moles is going to be equal to, I should probably say moles of potassium. This is my known substance. So I'm working out the mass of the moles of my known substance now. And that's going to be equal to, like I said, mass divided by molar mass. So it's going to be 50 divided by 24. Okay, so that looks like it's going to be a little over 2. Cool. All right, so anybody's been confused for the last couple of seconds. I should have been written magnesium, not potassium, but the molar mass of magnesium is 24 grams, so I'm doing the right equation. So 50 divided by 24 is 2.83, which looks about right. 2.083, I should say. Let's just put 2.08 moles. Stage 4, what I do is I look at the equation and I think, what's the ratio of one to the other? So it's 2 to 1. So for every 2 moles, and this is in terms of moles, for every 2 moles of magnesium, I would be using 1 mole of oxygen. So I'm going to just divide that number by 2. So I'm going to say moles of the target substance, which is moles of oxygen, is equal to 1.04 moles. Final stage, I'm going to use the equation which I used earlier on to convert back into mass of the known substance. Mass of O2 is equal to, and the mass is equal to moles times the molar mass. Moles of oxygen is 32. The molar mass of oxygen is 32. Moles is 1.04, so it's 1.04 times 32. So that should be equal to 33.3 occurring. So, and that's the amount of grams. So that should be the amount we should get. Now the follow-up question might be for this question, when they carried out the experiment, they got 25 grams, and they might get, so that what they mean by this is what we would call the actual yield, or just the yield. That's the amount that they actually got of the product, 25 grams. They might ask 2 questions at this point, or they might say, why did you not get the the full amount. What were the possible reasons for not getting the full amount? And the reason would be, so there are a number of different reasons that you could say. So you're going to be talking about spillages, and you're going to be talking about how not every single last molecule of the reactants is going to manage to come into contact with every single last molecule of the other reactant in it. So that's one of the sort of explanation questions. And then there's going to be the calculation question, which is going to be, what is the percentage yield? So there is a formula for this, but again, it makes sense to kind of understand the formula from common sense. So the percentage yield, let's understand what it means. It means simply what percentage of the maximum yield, which we've worked out here, did we actually get? We got 25 grams, so we're simply asking what percentage of 33.3 is 25 grams. Right, so you're just going to do 25 over 33.3, and then times 100 to turn it into a percentage, which on this occasion gives me around about 75%.